been 2 years since NASA's James Webb telescope gave us a stunning first look at the depths of our universe.
Human curiosity has driven us to explore far beyond our home planet, leading us to Mercury, a world full of unexpected wonders.
This is the first time we get to orbit Mercury. We have done several flybys with Messenger 3 and with Mariner 10.
Imagine a place where the impossible becomes reality. A single day on Mercury lasts longer than an entire year, and temperatures soar high enough to melt lead. Despite its small size, Mercury has kept many of its secrets hidden, deceiving us for centuries. But thanks to our space-faring robots, we've begun to unveil the truths of this planet, revealing that even the tiniest worlds can hold the biggest surprises. Exploring the terrain of Mercury. The smallest planet in the solar system and the first planet out from the sun is Mercury. Its name is derived from the name of the ancient Roman god Mercurius, also known as Mercury, who was the god's messenger and also the god of trade and communication. Classified as a terrestrial planet, Mercury has a surface gravity that is similar to that of Mars. Because of the innumerable impact events that have accumulated over billions of years, Mercury's surface is severely cratered. Since Mercury is one of the solar system's 4 terrestrial planets, it is a rocky world similar to Earth. With an equatorial radius of 2,439.7 kilometers, it is the smallest planet in the solar system, 1,516.0 miles. Moreover, Mercury is more massive, but still smaller than Ganymede and Titan, the solar system's 2 largest natural satellites. About 70% of Mercury is made up of metallic elements, and the remaining 30% is silicate. Astronomers and space fans have always been intrigued by Mercury, a planet that's very different from the others. What more is Mercury hiding, and why is it so unique? For hundreds of years, Mercury has been a mystery. Because it's so close to the sun and spins quickly, it was hard for early scientists to observe, leaving much about this strange planet unknown. It was not until centuries of obscured view that its enigmatic terrain started to spill its mysteries due to tremendous advancements in space travel. Mercury, despite being the closest planet to the sun, has managed to astound scientists with its unique features and contribute to our understanding of the creation and development of planets. Mercury is one of the hardest planets to view from Earth because of its closeness to the sun. Even with modern telescopes, the planet often appears as a tiny, bright patch of light that is hard to distinguish from the sun's glare. Early astronomers made attempts to investigate Mercury's surface and surroundings, but their efforts were unsuccessful for many years. Nevertheless, the discovery of area journey in the second half of the 20th century heralded a significant advancement in our understanding of Mercury. The mysterious geography of Mercury was first explored in 1973 by NASA's Mariner 10 mission. The first spacecraft to visit Mercury, Mariner 10 revealed to humanity the planet's surface in close-up during a flyby. The mission discovered 10 surfaces covered in craters and ridges resembling our moon. This discovery came as a surprise because many scientists had assumed that Mercury's floor would change similarly to Earth's due to its length and proximity to the sun. However, Mariner 10 discovered that Mercury's floor has been severely damaged, suggesting a record of heavy impact from asteroids and comets. The information from Mariner 10 discovered huge plains. The scientists were truly astounded by the historical volcanic processes in these enigmatic craters, which spread around Mercury's floor in swirling. The origin of those holes isn't always fully understood, but it's thought to be connected to the planet's unique chemistry and unusual habitats. The world has vivid waves that are unlike any other planet. Another surprising discovery made by NASA's Mariner 10 was that Mercury has a completely robust magnetic planet. According to the researchers, Mercury is a small orbiting planet that no longer has the necessary conditions to expand a magnetic subject, so the presence of a magnetic subject indicated that Mercury's center was still liquid, which is a major revelation. But many concerns remained unanswered due to Mariner 10's limited information, and it took many years until it returned to Mercury for a thorough examination. The next crucial mission to Mercury was NASA's Messenger spacecraft, which was launched in 2004. The journey to uncover Mercury's enigmatic terrain started with NASA's Mariner 10 mission in 1973 and continued with the Messenger probe in 2004. Launched 31 years after Mariner 10, the Messenger mission, also known as the Mercury Surface, Space Environment, Geochemistry, and Ranging mission, broke new ground in our understanding of Mercury. In contrast to its Mariner 10, Messenger was intended to orbit Mercury, enabling a more thorough investigation of the planet. Messenger's mission yielded an astounding 200,000 images, including hitherto unobserved regions of Mercury. Mercury's darker side was found to have abnormally high levels of calcium and magnesium, one of Messenger's most fascinating discoveries. This sparked concerns regarding the mechanisms that might result in these concentrations. The mission also discovered that, in contrast to other planets, Mercury's magnetic field was surprisingly strong in the northern regions. These findings caused scientists to reevaluate their earlier theories about Mercury's interior composition and creation process. Magnetic fields are produced by the motion of liquid iron in the core of most planets, including Earth. Mercury, however, exhibits distinct magnetic behavior due to its distinct interior structure. What makes Mercury's terrain unique? However, what distinguishes Mercury's terrain from the rest? Not only are there hills and craters, but the surface is also subject to harsh weather. Mercury is hotter than any other planet, including Earth, because it is the planet closest to the Sun. Mercury can get as hot as 430 degrees Celsius during the day, which is more than 4 times the boiling temperature of water and also hot enough to melt lead. They not just experience extreme hot temperatures, but also extreme cold ones. They drop to a freezing minus 180 degrees Celsius at night. Mercury's tiny exosphere, which does nothing to store heat or regulate temperature, is the cause of this severe temperature variation. Recent research has revealed several unexpected surface features on Mercury despite these hostile circumstances. Evidence of volcanic activity on Mercury, including pyroclastic deposits from explosive volcanism, was discovered in 2012 by Messenger data. The long-held notion that Mercury was geologically dead was called into question by this discovery. Even more intriguing, researchers reported in 2020 that they had found aqueous ice in a few of Mercury's polar craters. On a planet this close to the Sun, these continuously shaded areas are cold enough to hold on to water ice. This finding has sparked new questions about how this came to be, and some of the questions have a valid explanation. It also poses the question as to if it's possible for life to exist on this extreme planet. Could these frozen havens be home to extremophiles, like those found in severe conditions on Earth? Bepi Colombo, the most current mission to Mercury, was jointly launched by the European Space Agency and the Japan Aerospace Exploration Agency in 2018 and is scheduled to arrive at Mercury in 2025. Even more comprehensive knowledge about Mercury's surface, including its chemical makeup and geological past, could be possible thanks to this mission. Mercury never ceases to amaze us, from its very strong magnetic field to the fact that it has water ice. But you're going to have to do an extra look at what we're going to discuss next. A day longer than a year. It sounds strange when we say a day is shorter than a year, but Mercury does. So how is it possible for a planet this close to the Sun to have a year that is shorter than its day? Typically, when we think about planets, we picture them orbiting the Sun once a day and rotating on their axis once. However, Mercury fascinatingly defies this convention. A year is actually shorter than a day in this tiny sunburned globe. Let's dissect this. One orbit of Mercury around the Sun is completed in just 88 Earth days. Due to their swift travel, Mercurian years are significantly shorter than ours, which take a whopping 365 days. This is where things get really intriguing, though. It takes an astounding 176 Earth days to complete one day on Mercury, or one full rotation on its axis. This implies that a year is only half as long as a day on Mercury. The Sun rises and then progressively gets bigger in the sky as it glides slowly across the skies, as if you were standing on the surface of Mercury. The Sun would appear to stop at some point, then appear to move backwards for a bit before continuing in its original trajectory. The reason for this bizarre dance is because Mercury's rotation is unable to match the speed of its orbit. Some genuinely strange results arise from this peculiar circumstance. The Sun's gravitational pull has slowed Mercury's rotation over billions of years, but why does it rotate so slowly? This is as a result of tidal locking to the Sun. Saying that Mercury is tidal locked to the Sun means that the planet's rotational period, the time it takes to rotate once on its axis, is synchronized with its orbital period, the time it takes to orbit the Sun. Which means the same side of Mercury always faces the Sun at perihelion, closest point to the Sun. The opposite side of Mercury always faces away from the Sun at aphelion, farthest point from the Sun. However, Mercury is not perfectly tidally locked. Scientists believe that Mercury is in a phenomenon known as a 3-to-2 spin-orbit resonance, which means that it rotates 3 times for every 2 orbits around the Sun, in contrast to our Moon, which is completely tidally locked to Earth. The impacts of Mercury's unique day-night cycle are severe. The side facing the Sun bakes in great heat for months at a time, while the night side stays in a freezing darkness for an equally long period of time, thus leading to some of the most extreme temperature variations in the solar system. Secrets of the planet. When discussing Mercury's atmosphere, or lack thereof, it's important to remember that the planet's meager atmosphere is referred to as an exosphere. Numerous processes regularly lose and replenish this extremely thin layer of gases to space. Mercury's fragile exosphere is sustained in part by the solar wind, radioactive decay, and even micrometeorite impacts. Observations conducted recently have uncovered some unexpected elements in Mercury's exosphere. Using data from the Messenger mission, scientists found in 2020 that there is more water vapor in Mercury's exosphere than previously believed. It is thought that the combination of oxygen in Mercury's surface rocks and hydrogen from the solar wind produces this water vapor. It is thought that the combination of oxygen in Mercury's surface rocks and hydrogen from the solar wind produces this water vapor. Mercury's long day and short year have an interesting effect on the planet's magnetic field. Mercury possesses a worldwide magnetic field, which startled scientists when they initially noticed it despite its small size and slow spin. According to recent research, Mercury's magnetic field is produced by a special dynamo effect in its liquid metal core, which is fueled by the planet's unusual rotational and orbital properties. Another intense secret of Mercury is its unexpected magnetic field. Unlike Venus and Mars, which have no global magnetic fields, Mercury's magnetic field, despite being far weaker than Earth's possessing just 1% of the Earth's magnetic field, is essential in shielding the planet's surface from the intense solar wind. Without it, Mercury's meager atmosphere would be destroyed even more quickly by the solar wind. Scientists were surprised by this discovery discovered by NASA's Messenger mission since they didn't think a small planet with a sluggish rotation could sustain a magnetic dynamo. A team led by planetary scientist Dr. Katherine Johnson of the University of British Columbia discovered something even more unexpected concerning Mercury's magnetic field. They found that the field is located approximately 20% of Mercury's radius away from the planet's center. Variations in Mercury's crustal thickness may be the cause of this offset as they impact the planet's inner heat flux. Additionally, there are some intriguing observational opportunities due to Mercury's slow rotation and fast orbit. The Sun appears to stand motionless in the sky at certain times near certain hot poles, which are specific locations on Mercury's surface. The planet's most intense heat is felt at these hot poles. Conversely, certain regions close to Mercury's poles receive no sunlight at all. Water ice has been found in permanently shadowed craters on Mercury's poles, which is one of the most fascinating recent findings about the planet. Dr. Nancy Chabot participated in this study as well. Researchers have discovered indications of water ice in these areas that are permanently shaded. However, on a planet this near to the Sun, how can ice survive? It's all because of Mercury's distinct rotation and orbit. Even if the surrounding areas burn in the Sun's heat, the permanently shadowed craters on Mercury's poles remain extremely chilly because they never get direct sunlight. Scientists are now wondering if any other volatile materials, such as organic chemicals, could be kept in these cold traps in light of this discovery. Mercury's lengthy day and short year have an impact on how we study the planet. Reaching Mercury is difficult for spacecraft because of its rapid orbit around the Sun. To slow down sufficiently to enter an orbit around the planet, they must perform a series of intricate maneuvers, such as repeated flybys of Mercury and Venus. These gravitational pulls will help the Bepi-Colombo mission, which is presently traveling to Mercury, gradually modify its course and speed. The spacecraft was launched in 2018, but it won't reach Mercury's orbit until 2025, that is, after 9 planetary flybys. Bepi-Colombo will encounter additional difficulties after entering orbit because of Mercury's peculiar day-night cycle. The spacecraft will have to balance keeping electricity throughout the long, chilly nights with carefully controlling its exposure to Mercury's strong daytime heat. This fine balance, which emphasizes the harsh conditions brought about by Mercury's particular spin and orbit, is essential to the mission's success. New insights into how Mercury came to have its current rotation rate have been revealed by recent computer simulations. According to these simulations, Mercury may have originally rotated far more quickly before being slowed down by the gravitational pull of the Sun and huge asteroids or comets. This study contributes to our understanding of the evolution of not only Mercury, but also other planets in our solar system. As we continue to study this planet, new questions arise like, how does the planet's core remain partially liquid despite the long nights and extreme cold? What impact has Mercury's peculiar orbit had on the formation of its geology? These inquiries serve as a reminder that there are still a lot of unanswered issues about our own solar system. Because of Mercury's distinctive features, we are forced to reevaluate current beliefs and consider novel avenues for inquiry into the formation and evolution of planets. Mercury's hidden depths. Mercury harbors more mysteries as we have been revealing. Mercury still confounds scientists with its peculiarities and surprising properties despite its size. The extraordinarily huge core of Mercury is one of its most fascinating secrets. A study performed by planetary scientist Dr. Nancy Chabot of the Johns Hopkins Applied Physics Laboratory found that around 85% of Mercury's bulk is made up of its core. Compared to the Earth's core, which makes up only 15% of the planet's volume, this is far larger. However, why is Mercury's core so massive? According to one idea, Mercury was previously considerably larger and was destroyed in a major impact early in the solar system, losing most of its outer layers. This concept, referred to as the hit-and-run scenario, was put forth by a University of Arizona physician, Dr. Eric Asfog. This idea suggests that Mercury may have been struck by a giant planetesimal that removed much of its crust and mantle, leaving behind the iron-rich core that is visible today. The puzzles, however, don't end there. Sulfur, potassium, and sodium were among the volatile components found on Mercury's surface, according to a 2020 scientific announcement. Finding these elements on a planet this near to the Sun was surprising because they usually evaporate quickly at high temperatures. Dr. Patrick Poplawski of the Johns Hopkins Applied Physics Laboratory proposed that comets or asteroids may have transported these volatile elements to Mercury subsequent to the planet's formation. Mercury's craters contain signs of organic substances, according to scientists. These so-called dark deposits may consist of intricate carbon-based compounds, akin to those that may have been involved in the emergence of life on Earth. Could there be hints about the origins of life in our solar system on Mercury, despite its hostile environment? Unexpected geological activity on Mercury is another dangerous mystery. For many years, geologists believed that Mercury was a lifeless planet. Messenger mission data, however, showed signs of very recent volcanic activity. On Mercury's surface, Dr. David Rothery of the UK's Open University discovered little, brilliant dots that seem to be volcanic vents. Known as hollows, these characteristics imply that Mercury might be geologically active even now. Mercury's chaotic terrain, a sizable region of disorganized hills and valleys close to the planet's south pole, is one of the most perplexing aspects of the planet. This region, roughly the size of Texas, was originally seen by the Mariner 10 mission in the 1970s. according to a theory put out by Dr. Thomas Waters of the Smithsonian Institution. As Mercury's orbit changed, the sun's tidal forces may have generated enormous earthquakes that created this topography. Surprising insights regarding Mercury's composition have also been uncovered by recent studies. Mercury's internal structure was examined by Dr. Amir Khan of the University of Zurich using information from the MESSENGER mission. His team discovered that, like Earth, Mercury's core is most likely made up of a solid inner core and a liquid outer layer. Mercury's inner core is, however, substantially larger than Earth's, which may account for some of the planet's peculiar magnetic characteristics. NASA's MESSENGER mission, which exploited minute changes in Mercury's gravitational field to map its interior structure, confirmed this peculiar composition of the planet's core. Approximately half of Mercury's total core is thought to consist of the solid inner core, which is believed to be 2,000 kilometers wide. Mercury has a thinner mantle than previously believed beneath its crust. Mercury's mantle may only be 420 kilometers thick, according to recent studies, while Earth's mantle is over 2,900 kilometers thick. This thin mantle affects Mercury's geological activity and how it disperses heat. 2020 saw the publication of another groundbreaking finding regarding Mercury's subsurface by scientists utilizing data from MESSENGER. They discovered proof of a huge magma pool that formerly existed beneath Mercury. This extinct magma ocean most likely had a significant influence on the internal and surface structure of Mercury. Some of Mercury's distinctive surface features, such as the large, smooth plains that span a large portion of its northern hemisphere, may be explained by the existence of this old magma ocean. Known as the Northern Volcanic Plains, these plains are assumed to have been formed early in Mercury's history by huge lava flows. These profound mysteries of Mercury put our knowledge of planetary origin and evolution to the test. Nitrogen trapped beneath Mercury's surface. Scientists who examined MESSENGER data discovered proof of nitrogen trapped below Mercury's surface. This nitrogen may represent the remains of a former atmosphere that was forced underground by the planet's extreme heat and solar radiation. Subterranean nitrogen presents interesting issues concerning Mercury's history. Was there formerly a thicker atmosphere on the planet? What effects on its early climate and possible habitability may this have, if at all? Small landforms known as grabens were discovered in 2019 and were linked to several of Mercury's worst faults. These so-called grabens, basically little valleys created by the crust's extension, appear to be geologically young, indicating that Mercury's crust is continuously moving and settling. The potential for underlying fissures and fractures that could offer channels for heat and possibly even fluids to pass through the planet's crust is another peculiar feature of Mercury's hidden depths. Although the possibility of subterranean water on Mercury may seem unlikely, such occurrences have been noted on other ostensibly hostile planets in our solar system. For example, the icy crusts of Jupiter's moon Europa and Saturn's moon Enceladus both conceal oceans below the surface. Even though Mercury has a completely different environment than Earth, underground water is still a possibility. Every new finding regarding its secret depths advances our knowledge of this amazing globe and offers important new perspectives on the genesis and evolution of planets throughout the solar system. One thing is certain as we anticipate next explorations and missions: Mercury still has a lot of mysteries to be solved, despite its small size and close proximity to the Sun. Anticipated further discoveries in Mercury. As scientists build more sophisticated models to predict the behavior of those far-off planets, our understanding of Mercury's orbit within the larger solar system expands along with our understanding of the planet's behavior. Mercury's unique properties make it an excellent laboratory for studying the formation and evolution of planets. For instance, a planet's thick and thin mantles provide important clues about how the Sun was formed. By studying Mercury, scientists can also understand the circumstances surrounding the formation of the internal planets that make up Earth. Additionally, Mercury has a special place in human culture and mythology. In Roman mythology, Mercury became the god's messenger and was known for his speed and agility. Despite its close proximity to Earth, Mercury is one of the least studied planets within the solar system due to the difficult conditions of sending spacecraft there and its harsh environment. However, the success of missions like Mariner 10 and Messenger has demonstrated that it is far more viable to unlock the secrets and techniques of this mysterious planet. Mercury is the quickest planet within the solar system, completing one orbit across the Sun in only 88 days, which appears fast. The fast tempo of globalization has been indicative of the velocity and alternation of various cultures at some point in records. Looking forward, a joint project between the European Space Agency and the Japan Aerospace Exploration Agency was created to observe Mercury in a way never seen before. It includes orbiters, the Mercury Planetary Orbiter MOO and the Mercury Magnetic Orbiter MMO. The European Space Agency's Bepi-Colombo mission, which was launched in 2020-2018, is expected to build on the discoveries made by earlier missions and provide specific statistics about the floor of Mercury's inner and magnetic fields. Astronomers will work together to conduct a comprehensive observation of Mercury's magnetic field and floor surrounds, providing fresh information on the planet's interior structure and floor design. One of the primary objectives of the Bepi-Colombo mission is to enhance our understanding of Earth's magnetic field with unprecedented accuracy, which will enable scientists to trace the formation and development of Mercury's magnetic field. By doing so, researchers aim to gain deeper insights into how Mercury generates and sustains its magnetic field, offering broader implications for our knowledge of planetary structures as a whole. This information could also be pivotal in studying exoplanets and their magnetic fields. The mission involves detailed investigations into Earth's records and the characteristics of Mercury's surface, with a focus on its magnetic properties. Additionally, the mission will employ advanced cameras and spectrometers to produce highly detailed maps of Mercury's surface. This data will allow scientists to reconstruct the history of the planet's volcanic activity and assess its significance in Mercury's overall evolutionary process, uncovering new details about its composition and the forces that have shaped it over billions of years. Another objective of Bepi-Colombo is to monitor the interaction between the sun wind and the exosphere, Mercury's thin outer layer. Mercury's exosphere consists of atoms and molecules that are ejected from the planet's surface by the solar wind and accumulate in its harsh environment. This material is constantly replenished, and by studying the dynamics and composition of the exosphere, the Bepi-Colombo mission will shed new light on the processes that govern the interactions between a planet's surface and its surroundings. Although the mission will take several years, with the spacecraft expected to arrive at Mercury in 2025, many mysteries surrounding this intriguing planet remain. Despite its proximity to the Sun, Mercury is a planet of vulnerability, holding a magnetic field that defies expectations. Its distinctive characteristics and complex history challenge our scientific understanding, ensuring that Mercury will continue to captivate researchers and remain a subject of study for years to come. Water ice found in the shadowed craters of Mercury may hold evidence of ancient volcanic activity, a possibility supported by data from missions like Mariner 10 and Messenger. These missions have been instrumental in deepening our understanding of Mercury's geology, composition, and magnetic field. However, much about the planet remains unknown. As we continue to study Mercury, we anticipate uncovering further surprises and challenges, which will enhance our knowledge of the processes that shaped not only this planet, but the entire solar system. Thanks for watching. We'll see you in the next video.